Hello everyone. Today we're going to have a little discussion about the gravitational force. All right. So the gravitational force is also known as the weight of an object. So these two terms are used interchangeably. So if I say the weight, I mean the gravitational force. If I say the gravitational force, I mean the weight. They're the same thing. So this is the force that we'll get whenever we put two objects near each other in a gravitational field, and that'll pull them together. So when you feel your weight, this is the force that you're feeling, the force that gravity pulls on you with. And we calculate this pretty simply. F with the subscript g is going to be our force of gravity or the weight of the object. M is going to be the mass of the object. And this little g, we're going to use that. That's our acceleration due to gravity. We're going to start using this little g instead of an a for acceleration. Because it's a very specific acceleration, and we're going to see that in some later problems, we're going to also want to use a for acceleration at a different time. All right. So we're also going to use the positive version of the 9.81 meters per second squared. We're going to calculate the force, and then we'll use our free body diagrams to determine whether or not a force is a positive force or a negative force. Since this is a force, we're going to measure it in newtons. All right. So when we measure weight, we measure in newtons. And now normally we would think about ourselves measuring our weight in pounds. And that's the English unit for weight. All right. Now the metric unit is going to be newtons. So why isn't it kilograms like we would normally think of? Well, kilograms is actually a mass, and they're really not the same thing. So kilograms and pounds are not the same unit. All right. One measures a force, pounds measures a force, and kilogram measures a mass, which we know to be the amount of inertia of an object. So we're going to do three quick examples using this equation. The first one, what is the weight of the object if it's 25 kilograms worth of mass? So if we're solving for the weight, that means our gravitational force is our unknown. Our mass here is given to be 25 kilograms. And we're going to use the acceleration due to gravity, g, of 9.81 meters per second squared. So we'll just go ahead and substitute all these variables into the equation that we have, solving for the gravitational force or the weight of the object. All right, weight being Fg. So we have 25 kilograms of mass times 9.81 meters per second squared worth of acceleration, and we get a gravitational force of 245.25 newtons. All right, and so that's the weight of a 25 kilogram object. All right, what about the mass of a 25 Newton object? Well, 25 newtons is a measurement of force, all right? And so if we're saying an object is 25 newtons, then we're saying that the weight of the object is 25 newtons. And so that is one of our givens, 25 newtons. We're looking for the mass, that's our unknown. Acceleration due to gravity, we know is 9.81 meters per second squared. So we will use our equation again. All right, this time the 25 is over on the left side as a newton, as a force. We're looking for the mass. We're going to divide both sides by 9.81 meters per second squared to get our mass here. All right, and so when we figure this out, we get 2.55 kilograms worth of mass. Now, as I said before, we're used to measuring our weight in pounds instead of newtons, right? But since we're dealing with metric, then we want to be in newtons. So 135 pounds is the weight of the object, so it is the force of gravity acting on that object. But we can't use our other units here to solve for mass, all right? So we need to switch this over to newtons. So we would go to our resource sheet, and we find that there are 4.448 newtons in 1 pound. All right, so if I figure out how many newtons 135 pounds is, then I get 600.48 newtons. And that's what I'm going to use as my force of gravity to determine my mass. All right. So I'll use my equation again, set everything up. The force of gravity, or the weight, is equal to the mass times the acceleration due to gravity. I use 600.48 newtons. And I'll go ahead and just simply divide. And I get 61.21 kilograms. All right. So why is it that when we stand on a scale, we see both kilograms and we see pounds when they're not the same thing? Well, pounds are the units that we use for force. That measures weight. Kilograms are what everybody else will use to measure their masses. So how does it work on a scale? Well, the scale is just calibrated to show both of those numbers at the same time. But how does it do that? Well, it actually takes this 9.81 meters per second squared into account when it's doing the calculation or when it's doing that conversion on the wheel. So, all right, that means that if you were to take a bathroom scale to the moon, since the acceleration would be different on the moon, you would not see the correct mass shown on the scale. You would see the correct weight, pounds, but you would not see the correct mass because it uses a number that only works here on Earth. All right. So that is the gravitational force and some quick calculation. We're going to use these as a part of some of our other calculations later. All right.